the figure, can you say anything? What it is that interparticle friction and flow characteristics? One funnel is given, pile of powder it is given. Okay, what it is that? Now, this is, as I said, it is a powder form. Okay, what we are going to get the metal. Okay, so the different methods and different process we have been carried out. So in order to get the metal into a powder form. Okay. So here, if you take the topic interparticle friction and flow characteristics, here the friction between the particles. Okay, friction between the particles, which will be affecting the ability of the powder to flow readily and to pack tightly. Okay, you can see if you put some fine size of the powder, if you are going to pour some flour. Okay, by using funnel he is taking some sort of pyramid, or it will be forming some sort of triangular section. It will get formed if the powder sizes are very coarse. Okay, if it is having some size and size of that. Okay, then it won't be having a pyramid shape, it won't be coming a triangular shape, it won't be getting. If it is a fine form of the powder, okay, then we are going to get the triangular shapes. It will be get builded over the whenever we are going to pour the powder on the floor or anything. Okay, so the same thing here. The friction between the particles, the friction between the powder particles, which will be affecting the affects the ability of the powder to flow rapidly and pack tightly. And for that we will be having a one test over here. We will be having a angle of responsiveness, you can see in the figure, which is formed. This angle is formed by the oil of the powder as they poured from the narrow funnel. So here we are going to pour the powder material over that funnel. Whenever we are going to pour the powder material over that funnel, so it will be forming an angle of repose. It will be get formed. Okay, angle of repose it will be get formed. Okay, so that it will be caused due to the friction interparticle friction between the powder particles. See, so many students are joining now. Okay, and also the smaller the particle sizes, generally it will be showing a greater friction and the repose angle, because as I said, when it is having a fine sized particle or a small sized powder particle, if it is present, okay, then the friction between that sand particles, friction between that powder also it will be more, and also it will be forming a steeper type of the angles. It will be get formed when we are going to pour from the funnel. And also I said it will be the size of that powder particles are getting more. Okay, then due to that there won't be a sort of friction won't be takes place between the powder particles. Then the flowability it will be more. The flowability it will be more. Okay, so with respect to this, we will be by considering the smaller size particles. The powder particles it will be showing a greater friction and also having an angle of repose. Okay, so that is the thing related to particles and interparticle friction and flow characteristics.
Sir Nagesh.
Sir, good morning, sir.
Morning, sir. PPT ಹಾಕಿದ್ರಾ?
Sir, PPT ಹಾಕಿದ್ದೀನಿ sir.
ಹೌದಾ, PPT ಬರ್ತಿಲ್ಲಲ್ಲ ಯಾಕೋ ನನಗೆ. ಇನ್ನೊಂದ್ಸರಿ ಜಾಯಿನ್ ಆಗ್ತೀನಿ. Let me join once again.
So, students, the PPT is visible, right?
Yes, sir.
Okay, I'll leave and once again join.
So next one is compressibility of metal powders. What is this compressibility of metal powders?
Yes, sir.
Okay, so what is the compressibility of the metal powders? You can see here, uh, we have already came what is that different methods. So now it is visible, sir.
Sir, it is visible now. There was a problem from my side only. Thank you, sir. Please continue. Which chapter, sir?
Sir, this is model polymers and metal powder metallurgy, sir.
Model number ಎಷ್ಟು ಸರ್ ಇದು?
4 sir.
4. CO K2 ಆಗುತ್ತಾ?
Yes sir, it is K2 sir.
Sir. Continue sir, continue. I'll just take a snap.
Okay sir, okay sir. So now, what do you mean by compressibility? So now we have came across different methods also. Okay, and also we have studied what are the friction between the sand particles. So based on that sand particles, size of that sand particle, powder. So how the angle and also flow characters it will be get varied. Now the next, sir.
ಯಾವ್ದು B section ಇದು? B section,
B section, sir. B section.
Okay, sir. Thank you. Continue, sir. Thank you. Please continue.
Okay, sir. So now the thing is that the topic is compressibility of metal powder. Okay, if you go for the compressibility of the metal powder, so we need to what do you mean? Can you tell me what do you mean by compressibility? Yes, anyone? And the compactability? Yes, any answer? Okay. Now if you go for the compressibility, okay. So if you consider the powder, the compressibility of the powder, sir, it will be playing a major factor in the design. Okay, like in case of the pressing tools, and ability of the attainability and ability of the size of pressing of the powder, and also densification of the what are the powder what we are using. Okay, so this will be this compressibility of the powder based on the size and also shape of the particle, shape of the powder particle. It will be giving a better productivity without any defects. Okay, and with good surface finish. What are the properties we require? So all those things can be attained by getting the compressibility as well as the compactability of the powder. Okay, so in order to get that, the compressibility of the powder, so what are the factors it will be influencing on the powder metallurgy? So in that first one, let me take inert hardness of the metal or alloy. Second one, particle size, as I said, internal porosity, particle size distribution, and presence of non-metallic, and use of solid lubricants. So these are the things, these are the some of the factors influencing. So in order to get the compressibility of the powder, let me take the first one, inert hardness of the metal or alloy. So in this inert hardness of the metal or alloy, there the powder particles undergo considerable deformation. So here the powder particles will be undergoing deformation during pressing, and the strong influence on the compressibility which will be taken place, okay, when it is undergoing the pressing process. Okay, so here in the first point, inert hardness of the metals or alloys. So what are the powder particles? It will be considered which will be undergoing deformation during the pressing process. Okay, and it will be having a strong influence on the compressibility. Okay, that is the first point, it is related. Then the second point is particle size. So already I am saying from the start of this powder metallurgy, here the very important factors it will be played by the particle size as well as on the shape. Okay, so if I consider the particle shape, the irregular of the powders, it will be having the less compressibility. The irregular shape of the powders, you have came across many different sizes, shapes. So you can see needle, irregular as well as branch like, okay, large and thin. Okay, same way different types of the shapes you have came. Okay, so due to this presence of the uh, sizes also, shapes also, this compressibility it will be get dependent, and it is said that if we have a more irregularities, then what are the powders it will be showing a less compressibility. So next one is internal porosity. So what is this internal porosity? What do you mean by porosity? See, what do you mean by compressibility? You didn't say. What do you mean by porosity?
Sir, air to remove air.
To remove air. Okay. Then now see porosity if I consider. That too it is an internal porosity. Okay, so it lends to so if I consider the thing porosity means some sort of holes or gaps when we are doing some sort of pressing or anything, it will be get carried out. If the size of the particles, as I said, the particle size, okay, based on the particle size, if it is finely packed, then there won't be any sort of the porosities, it will be formed on the surface of the material, whatever the thing which you have been get produced. Okay, so based on the fine particle size and shape, the porosity, internal porosity, it will be get dependent. So if I go for that, this internal porosity in a powders, and it will be becomes isolated during the pressing, and it will become isolated during the pressing, and this traps air within the particles, and it will be trapping the air within the particles. So now the air is highly compressible. Okay, air is highly compressible or incompressible? So that also you don't know. Okay, so this
Compressible, sir.
yeah, it is compressible. Air is highly compressible. Okay, but it depends upon the what are the amount of quantity you are taken and whatever it may be. Okay, so that whatever the traps air it has been entrapped in the particle. Okay, it has to be get released out. Okay, when if it is present inside the what are the powder itself or the component prepared by the powder, so then it leads to the formation of the internal porosities, it will be get formed. Okay, so for compressibility here, the powders, in order to get the powders, we need to have a highest compressibility should be taken place. Okay, so high compressible should be taken place. Then what all that airs are entrapped inside the component that we are manufacturing. So those things it can be get escaped. Then particle size distribution. So with this particle size distribution, so we need to have a uniform distribution of the particles should be there in order to avoid the poor compressibility. So here it will be get all the one point to another point. It is interlinked. Okay, particle size, particle shape, internal porosity. So all these are interlinked characteristics only. Okay, if the particle size distribution is not proper, it is not uniform, then obviously what all the internal airs are trapped inside that. Due to the trapping of that internal airs, then the porosity will become internal porosity. It will be get caused. If the particle size is not regular, then obviously if it is not regular, then particle size distribution also won't be regular and won't be uniform. Okay, so it should be a uniform size it should be present. If it is not present, it will be showing a poor compressibility. It will be taken place. Okay, so then this will be add as one of the point which will be characteristics of the compressibility. And presence of non-metallics. So non-metallics such as unreduced oxides reduces the compressibility, and also it will be showing the properties like hardness as well as low specific gravity. Okay, here the presence of non-metallics. So the non-metallics it will be reduced as the oxides. Okay, reduced oxides and also reduces the compressibility and also shows the properties like hardness and low specific gravity. Now the next one is use of solid lubricant. So it is also one of the characteristic. Okay, so in order to get the good bonding between the one powder to another powder, obviously we need lubricants. The lubricants are added during the pressing by using the different machineries. Okay, it will be showing the compressibility, good compressibility properties that will be shown while the pressing process is undergone. Okay, so these are the things related to the compressibility of the metal powder. Okay, so when component is get prepared, the sort of compressibility over that powder particle with some other ingredients by using the machine, pressing machine or anything it may be, to develop a product. So these characters it will be playing a very important role. So in order to get a good product, in order to get a good surface product, in order to get a defect-free product. Okay, so we need to follow this consideration of this characteristics of compressibility